Hello everyone, welcome back to our Hyperledger Besu development series. Today we are going to see how to set up private network using QBFT consensus. So let's get started. So here you are using QBFT consensus, which is proof of authority. Use this tutorial for education purpose only, as we are following official documentation. We must have installed Besu on our system. Let's go to the first step. We have to create empty folder directories in our main directory as one node 1 to node 4 and one same data folder in each directory. Here you can see I have created node 1 to node 4 and one data folder. Let's go to the second step, where we have to create QBFT config file JSON in our main directory. Let's just copy this config code and paste it there. Yeah, here you can see chain ID, engine, and addresses and funds allocated to each address. Let's go to the third step, where we have to create keys and genesis file for odd nodes. Let's copy this command, redirect to the main directory. Let's remove these previous terminals. We will do it again from scratch. Let's redirect to our main directory. Paste that command. It will automatically generate keys for all nodes and genesis file. Here you can see key and key.pub file for each node and genesis file, where all data is given, like chain ID, consensus engine, and addresses and its allocated fund. Here is one more extra part, is extra data. As we are using POA network, extra data must be presented in our genesis file. We are following this structure, this folder structure. Let's go to the next step. Here we have to move those files in our node directories in data folder. So let's do it. Let's move one by one these files to our node directories. Either we can copy or we can directly move. Let's do it one by one. For node 3 and last for node 4 also. Yeah. Let's again go to the documentation, where you can see we have shifted all the key files in respective directories. Let's start our first node. For that we have to redirect particular directory of node 1, and same for all other nodes, node 2, node 3 and node 4. Create separate terminal for each node so we can query the data. let's copy this command to start our first node. Before that we have to update that command. If you want to connect our RPC URL with get console and query data, we must have to do some changes. Like we have to just add admin API so we can query the node related data, means peer related data. Just copy this command and paste in our first terminal. Maybe there is an issue, let me check. Okay, we have to move our genesis file from this uh, network file folder to our main directory. Let's move it. Now it will work. Just paste this command. Here you can see node 1 is initialized. Similarly for node 2. For that, copy this command. We have to add inode address of first node in our command, so let's paste it somewhere. For same for node 3 and node 4, just copy node 3 command and node 4 command. We can change it using global finder. So let's copy that node 1 in node URL, Control F, and just replace our first node inode URL in that place. Replace in all commands. Let's documentation. So similarly for other node also we have to paste all commands, like node 3, node 4. Let's go to the node 2 directory and paste first command. It will initialize node 2. Here you can see logs. Similarly for node 3, copy second command, paste it in node 3 directory. It will also initialize node 3. Similarly for last node. Here you can see all node are initialized and peer-to-peer connection as we have added it in our command itself, boot nodes URL. So sometime it will take time. So let's check. It will take time to sync. Here you can see block production is started, and here you can see block produced, block imported. So all 4 nodes are in peer-to-peer connection and creating blocks. In order to check whether our network is working properly or not, let's copy this curl command and paste it in new terminal so we can get response. If we are getting response, that's mean our network is working properly. Let's see. Let's query our data using get console. For that, get attach and RPC URL of any node. So we are using first node RPC URL, HTTP URL. So it is showing it is unable to connect. Let me check what is the problem. So let's see. Okay, I think I have. Okay, let me check in terminal once. What is our RPC URL for node 1? I think it must be work on 8545. Yeah, it is. So let's try it again. Paste http:// and paste URL. Now it will work. Yeah, here you can see we have successfully attached our get CLI with our running node. So just check the API, admin API. We have added it in start our command of first node. Here you can see all peer data. Those are 3 peer are connected to first node. We can see all data node addresses and its ports on which it is working, it is running, sorry. So here you can see node 1 data, node 2 and node 3, means except first node, 2, 3 and 4 node data, peer data. Let's see which commands are available in our terminal for development. Those are admin APIs. So one more API is ETH APIs, which is used in transaction as we are doing Web3 interactions. We can check block number also, it.block number. Here you can see we can match that block number with our latest blocks also, so it is same, it is showing correct data. So let's exit the terminal. Let's try to add it in our MetaMask and do some transaction. For that go to the MetaMask, check whether that network is available or not, then add it manually. Network name Besu QB, paste the URL, RPC URL 1337. Let's replace it again. Now it is working, it is fetching the chain ID automatically. Type the network name, okay, QBFT. Save. Here you can see now it is working, it is showing allocated balance. So for that address we have added in Genesis file. Let's do the transaction. Before that we can remove the activity log data, so it will not reject our transaction as we are using same port for multiple times. I have developed on Light Explorer EVM compatible. It is compatible to all EVM blockchain. It will show latest data, so we can verify by block number also. It is showing same block number in Explorer as well as in our running node. We can verify it also. Let's do a transaction. Here you can see latest node data, latest block data. Let's do a transaction on our custom Besu node. Let's transfer one token to some another address. It should work now. Let's see. We have to wait for some time. Yeah, here you can see transaction is successful. Here you can see query the all transaction related data. One token we transferred, gas price, gas used. That's all for this video. Follow for our next videos.